So here, when I'm looking for the domain, for the root of sine pi x to be defined, sine pi of x is greater than or equal to 0. And now here, this is my constraint. So I want to find where sine pi of x is greater than 0. So what I'm going to do is I'm going to start with the sine chart. And I remember the sine chart using the graph, 0, pi, 2 pi, minus 2 pi. And now I have a multiplication inside the function. And remember with our transformations, if we multiply inside the function, that is a horizontal compression by a factor one over pi, or 1 over whatever that value is. So now I'm going to divide everything by pi. To give me updating these numbers, giving me 2, 1, minus 1, minus 2. And my range, or my domain, is minus 1 to 1. So I'm going to go here to here, and I'm including these points. And now I'm going to draw where the function is positive. Here it's positive, but now I want greater than or equal to 0. So I need to include where it's 0. So I include these 2 points, but I also include this point. Don't forget this point. So my interval is the set minus 1 unioned with 0 to 1. So the domain equals the set minus 1 union with the interval 0 to 1. And now we want to determine an expression for the derivative of this function using Leibniz notation and chain rule. Now with Leibniz notation, what we do is we start outside and replace with variables as we go along. So I have f of x equals root sine pi of x. And I'm going to go, okay, there's the most outside thing is that root. I'm going to let u be the stuff just inside of it. U equals sine pi of x. So f of u equals root u. And now with my sine pi of u, sine is the outside. This inside piece, I'm going to let v equal pi of x. Then u of v equals sine of v. Okay. Now, when I have du or df by dx, this equals df by du times du by dv times dv by dx, which equals the derivative with respect to sine pi of x, because that's what my u is, of the square root sine pi x to the 1/2. times, and now I'm taking the derivative of u with respect to v, or the derivative of sine pi x with respect to this pi of x, or what my v is, du by dv. This is u, this is v, times the derivative of pi of x with respect to x. Okay. And now each of these, I just use the rule for that outmost function. So it equals, well, this is 1/2 times sine pi of x to the minus 1/2 times, now the derivative of sine of stuff is going to be cos of pi x times, and the derivative of pi x with respect to x is pi. And finally, I clean everything up. It's going to be pi over 2 times cos pi of x times divided by the root of sine pi of x.